Hello viewers. So in this video, we'll be looking at compositions of inverse functions. So for example, here, we want to find the composition of cosine inverse and cosine. So the first thing we should remember is we saw in the properties that if we have, since this is cosine, we have to recall this. We have to recall that if you have cosine inverse of cosine of x, this is going to be x, right? But when x is where? In the domain of cosine. X has to be in the domain of cosine. And what is the domain of cosine? The domain of cosine is 0 to pi. All right. So it means that the first thing we need to check is to see if 7 pi over 6. But if 7 pi over 6 is inside 0 to pi, then we would just say the answer is what? Is 7 pi over 6. But if you look at this, we know that 7 pi over 6 is not inside 0 pi. So this is not true. So it means that we cannot apply this directly. So let me just write it here. 7 pi over 6 does not belong to the interval 0 pi. Okay, so it means we have to do something else, right? Now, if you look, but 7 pi over 6, you can see this is in which quadrant? This is in quadrant number 3. So we have to use the reference angle now. So this will be cosine inverse. But in quadrant 3, we know that cosine is negative, right? So this will be minus cosine. And this will be 7 pi over 6 minus pi. So what we have used so far here is reference angle. So this will become cosine inverse of minus cosine. And this will be what? 7 pi over 6 minus pi is just going to be pi, it's just pi over 6, right? Okay. Now, another thing here is that we know that cosine inverse is not even. So since it's not even, we cannot cancel this minus here. And since also cosine inverse is not odd, we cannot take the minus outside. So the best thing to do is just to evaluate this. So this is cosine inverse. And this will be minus cosine pi over 6 is the same thing as cosine 30. Right? Yes. And what is cosine 30? Is root 3 over 2. Right. So it means that we just need to find cosine inverse of what? Of root 3 minus root 3 over 2. Okay, so this is back to what we did earlier. And how can we solve this one? We can solve this, the same procedure. In the last video, you will see to solve this type, we just say that y is cosine inverse. So y is equals to cosine inverse of minus root 3 over 2. And since this is cosine inverse is going to be in either the first or the second quadrant. Remember, the range of cosine inverse is 0 to pi. Remember this again. This is 0, this is pi over 2, this is pi, and this is minus pi over 2. So since the range of cosine inverse is either from 0 to pi, it means we could be in the first or in the what? in the second quadrant. Then, if you take cosine of both sides, you will have cosine y is equals to minus 3 over 2. Now, cosine is what? Is negative. In which quadrant? Is negative in the second and in the third quadrant, right? Okay. So now, what does this mean? This means that we have a common quadrant, and the quadrant number what? 2. Okay. And if we're in quadrant 2, we know how to get the reference here. In quadrant 2, we know our y is going to be pi minus pi star, right? All right. So, first of all, we need to get what is y star. Y star is an angle in the first quadrant whose cosine is going to be root 3 over 2, right? And what is that? That is simply pi over what? Pi over 6. Because pi over 6 is the same thing as 30 degree. Cosine 30 is root 3 over 2. You can see that we didn't need to bother about the minus, right? Now, since we are in what? In quadrant 2, we know that the original y is going to be the same as what? Pi minus y star. So y is just going to be pi minus pi over 6. And this simply tells us that this is 5 pi over what? Over 6. And that is the final answer. So remember, we started by composition, and we got to this part, which is cosine inverse of this. And what is cosine inverse of minus root 3 over 2? It's just 5 pi over 6. So it means the final answer, our final answer is just 5 pi over 6. All right. So similarly here now we are composing between cosine, sine inverse, and sine. So here we're going to recall that sine, if you have sine inverse, compose sine. If you have sine inverse, compose sine, this is going to be x if only x is inside the domain of sine, which is minus pi over 2 to pi over 2. All right. So the first thing we need to check now is we will check that 5 pi over 4. And you can see that 5 pi over 4 is still not inside what? It's not inside this. So since it does not belong, then we have to use reference. But if you look at this 5 pi over 4 is in which quadrant? Definitely, it's still in the third quadrant. So we will apply reference again. In the third quadrant, sine is negative, so you have minus sine. And this will be 5 pi over 4 minus what's minus pi. So this is reference angle. And this will become sine inverse of what? Here will be minus sine, and this will just be pi over 4, right? Okay. Now, if you look at this, you have various ways of doing this. We can bring the minus out, actually. We can bring this minus out. Why? Because sine inverse is odd. So I can write this as minus sine inverse of what? Of sine pi over 4. This is what, let me make this, the sine inverse is what is odd. Now, if you look at this, we can now apply this property because this is pi over 4. And this is just going to be observed that what's pi over 4 is inside what's is inside this domain, yes? Because if you have 1 over 4, this is what you have. This is minus pi over 2. This is pi over 2. So pi over 4 is going to be somewhere here, right? So definitely you're going to have pi over 4 somewhere. So it means we can use this property. So this is just going to be minus, the whole of this will just give us x. So this is minus pi over 4. And we're done. Okay. So this here, what have we used? We've used the fact that sine inverse sine of this is just minus 4. So let me see how I can better write this. This is just pi over 4. And then you have our minus here. So let's conclude. The conclusion now is that if you have sine inverse of sine of 5 pi over 4, it's just going to be minus over 4. All right. Now, let's do C here. Now, for C, we're dealing with tan. So for tan, it's still going to be a similar procedure. We need to check. We have to recall. What do we need to recall? We know that if you have tan inverse of what? Of tan x, this is E equals to x. What, when x is inside what's the domain of tan? And remember, the domain of tan we considered is only from minus pi over 2 to pi over 2. So the first thing we need to check is also to check what the angle that we have. If the angle is bigger than 360, we need to take coterminal first, right? Okay. But in this case, you can see that 4 pi over 3, it does not belong to this interval. Definitely, this is not inside. So it means that we have to use reference again. So directly, this is also in the third quadrant. So this will become tan. Yeah, so this will just become tan inverse of what? Tan, because we're in the third quadrant, then 4 pi over 3 minus pi. So, all right, so here you can see that the reason why this is pi over 3 is simply because we have this is, let me just write it here. The answer here is going to be just pi over 3. And since the reason is what? The reason is since pi over 3 is inside which interval? It's in the interval minus pi over 2 to pi over 2. So this is the final answer, just pi over 3.